So yes, thank you for coming. Thank you for attending. I know there's a lot of good seminars and options to choose from, so we thank you. As we were introduced, I've got 25 years plus experience. We've been using Revit since 2005, I think it was, and it wasn't a big thing back then. It was just software need. Since then, been in construction, been in the design world, and been as a consultant as well. Migrating people from the AutoCAD world to the Revit world. So a vast experience over 25 years and 3.5 years now in PCL. And my co-presenter is Andrew.
I'm Andrew Smith. I've got 16 years experience with PCL. I've studied architectural technology and I've worked as a project coordinator, field engineer, and ICT specialist in PCL, focusing on reality capture.
Okay, so who is PCL? I know many of you have heard the name, so I just got a couple of short facts about PCL. Been around since 1906, so about 119 years and counting. Over 5,700 employees, salaried and hourly across 30 offices in Canada, US, and Australia. We currently have, as our latest program says, just close to 1,800 active projects across the globe. Anywhere between the sectors of building, solar, civil infrastructure, heavy industrial, and special projects. So today's agenda, we're going to be looking at reality capture in its current form and how we use it at PCL and how it welcomes within the industry. And we're going to touch a little bit of looking ahead and what we foresee of what it can be. And I'll try not to be negative on that. But so what is reality capture? For some of you that don't know what reality capture is, it's basically using technology to capture existing conditions, right? What's physically there in front of us in a point cloud sort of mesh environment. Those are used for looking at space. It is used for future digital twin, a nice catchphrase you keep on hearing today. But really just capturing what is in front of us so we can use it in the advantages of our projects. And that's what we're going to do today. We're going to talk to you about how we're using it in different projects, different scopes, to give you an idea. So today's practice, reality capture means so many different things. We used to call it just laser scanning, but we put it in one bucket called reality capture. And in there, we're looking at total stations and surveying. A lot of total stations can do now scanning and taking the images and photographs. So what's the purpose of that? The 360 cameras. We're able to, using 360 cameras to go around projects, using for progress tracking on our sites. These are things that we do in every single one of our projects at PCL. The A360s are done weekly and uploaded, and we're looking at the progress tracking of those. Today, we're not going to be looking at that. We're going to be looking more of the laser scanning. I also have here mobile mapping, and I also have bathymetric. I have to try very hard to try and say that word, and I hope I didn't botch it. But and it's not something we've ventured into, but I just want to recognize there are other types of reality capture that is out there in the industry. So what we're going to be looking at is laser scanning. Laser scanning. You can use it through handheld devices, tripods, UAVs / drones, or even vehicles, right? And in the UAV world, we got the photogrammetry. So the scanning data comes on a point cloud that then we can use in a lot of different forms. And I said it before, so I won't repeat myself again. And we'll walk you through a lot of different projects that we've done and how we've taken advantage of it. There's no better person, to be honest with you, than Andrew. There's a lot of companies out there that do scanning. There's no question. And general contractors are doing it. Some consultants are doing it. Andrew's life has been around laser scanning for the last 5 years full time. So that's how much we've invested in it. And we're going to give you the reasons why. So I'll just let Andrew take off.
So I'm going to go through a couple of case studies that are examples of PCL projects where we've used reality capture in multiple aspects and it's worked out very successfully. So we're going to share some of those examples with you today. So the first example we're going to be talking about is Scotiabank Arena. And the main focus of this project was capturing the existing conditions. So this is an existing building. The challenge for us as a general contractor is to complete architectural, structural, mechanical, electrical renovations in multiple areas of an operating NHL, NBA, and concert venue. I'm sure none of us in this room have ever come across a situation where we've had to do work in an existing building and we don't have up-to-date, accurate as-built drawings, right? Never. So that was one of the main challenges that we encountered, is that we didn't have accurate information on the building. So it's a large, complex building, a lot of unique services. We're talking about concourses, public space, kitchens, concessions, washrooms, team spaces, dressing rooms, restaurants, media areas, AV, sound areas, back of house services, things like that. So it's a building, but there's a lot of things going on. It's a busy place. There's a lot going on. And our task was to pretty much scan and capture information on the entire building, the whole arena. So when it comes to schedule, because this is it's an operating NHL, NBA concert venue, the schedule is very sensitive. That's something that we have to work around. In order to get in there and capture the information, we have to work very closely with our clients in order to be able to do that. They've got they're an operating building, so they've got events, hockey games, basketball games, concerts, things like that going on. That's where they make their money. We're not able to interfere with that. We have to basically work around that. So working with the operations and events staff, we were able to plan and coordinate this work. To get in there and capture the existing conditions and incorporate that into the new design. So how did we actually do that? The process to break it down fairly simply is that we laser scan the existing conditions in the building. So that includes removing ceiling tiles and cutting access hatches to get access to above ceiling services. So things that you wouldn't normally be able to see, we had to get access to things like that. So we worked very closely with the client to coordinate that work. So to get in there and laser scan the existing conditions, that involved doing thousands of individual setups and combining all of that data into a single overall point cloud of the area. So the scanning process, like I was saying, it involves coordinating with the arena operations staff to get in, remove ceiling tiles, cut access hatches, gain access to pretty much anything that you can't see, because that's all information that we need to document as well. We used various methods of laser scanning to capture the information. So this included using tripod scanners, handheld scanners, long distance, longer range scanners to get into some of the tight mechanical electrical spaces above the ceiling. We found that it was better to use a handheld scanner to kind of get into some of those smaller, tighter spaces in order to capture that information. And we're also looking at doing UAV and drone flights over the building to capture the roof exterior of the building. So survey control points were used. While we were doing all of the scanning, we were using survey control points, and that allowed us to verify and validate the scan data. Once the scan data was done, we needed some way of verifying and making sure that it's right. We were using these survey control points to verify the scan data and the accuracy. From that information, from the 3D point clouds, we created 3D models of the existing conditions. So a 3D model was created of all the existing conditions, and that information was provided to the design team and the design consultants, who are then able to incorporate that existing information into the new design. One of the things that we found working on projects with existing buildings or renovation component is that sometimes the existing conditions are not factored in to the new design. You go to build the new design, you have clashes with the existing conditions. So we're able to avoid and eliminate those instances by capturing the existing conditions and incorporating it into the design. So this allowed us to reduce the risk of design coordination issues. So the consultants were utilizing the existing conditions model as a basis for their new design. They designed their new information around what's already existing so that when we go to build, everything's fully coordinated within that space. So like I mentioned, that's going to reduce the risk of changes to coordination, schedule impacts on site during construction, which is critical to our client who's operating an existing NHL and NBA concert venue. So in summary, using reality capture allowed the project team to reduce the risk of design issues, any unknown or inaccurate site conditions, coordination issues, schedule changes, budget changes, things like that that would result as a result of design issues during construction. So without this, the project would have encountered numerous design, coordination, and construction issues, which would result in redesign, which is going to have schedule and budget impact implications. So we were able to reduce those by capturing the existing conditions and using reality capture successfully. So we're currently on phase 5 of this project. We've successfully completed 4 phases of laser scanning and modeling, and the feedback from our clients, consultants, design team, construction team on site has been that this has been a really valuable process in reducing risk. They've continued to request this service, and to put it simply, they've found that it works. So we've continued to do it. The next example we're going to go through is the Rogers Center. We used reality capture to perform a lot of site coordination on this project. Again, the challenge as the general contractor is to complete architectural, structural, mechanical, and electrical renovations to multiple areas of an operating MLB stadium. Transforming the existing level 200 TD club behind home plate into an exclusive platinum club. Renovation scope includes construction of new stadia, premium seating, bars, kitchens, washrooms, dedicated exterior entrance, and a complete exterior patio building. So being a complex existing building, multiple renovations and updates over the years, here we were again faced with the challenge of, you guessed it, inaccurate as-built drawings. So again, we used reality capture, specifically laser scanning, to quickly and accurately capture the existing conditions and incorporate those conditions into the new design. This helped limit the risk and schedule impacts by reducing the unknown or inaccurate site conditions. So how did we do this, and what process did we follow? Similarly, we did laser scanning on site. We captured the existing conditions. That includes above ceiling mechanical and electrical service. So our scope of work included scanning level 100 and 200 concourse areas, 13 sections of seating, concessions, kitchens, team stores, washrooms, and back-end spaces. Again, we had to coordinate with the operations team to make sure that this work was done outside of their operating schedule. So during away games, when baseball wasn't being played and the stadium wasn't being used. Again, we used survey control points to geolocate the scan information so that when it's inserted into the model and the information is tied together, everything's using a shared coordinate system. In this case, the project team, we converted the point cloud that we created from laser scanning into a segmented mesh. So using software, we created a mesh surface out of the scan data, and this allowed us to classify information into things that are more useful, like columns, beams, slabs, walls, and we were able to classify the information so that when we're doing clash detection and coordination, we're easier able to determine what is it that's clashing with something else. So we were able to use the existing condition scan data to coordinate the new Stadia seating extensions, the Raker beam design, as well as verify and validate basically the new design. So comparing that with the shop drawings that we had got, making sure that everything's gonna fit prior to doing any construction. We performed weekly architectural, structural, and mechanical system clash coordination meetings, reviewing it with the design team and consultant to work out and identify any of the issues between the existing conditions and the new design, which resulted in catching various issues between different MEP services, identifying ceiling height issues, things like that, that we're all able to determine and catch before any construction started. So again, it's reducing the risk of coordination and construction issues on site. So we're able to use the scan data to measure the existing conditions, verify and validate constructability. We're able to confirm and verify the new ceiling heights while incorporating the existing conditions. And now that we have a fully coordinated design, we're basically just waiting for the Jays to win the World Series so that we can start construction on the project. So these are some examples and some screenshots of the clash detection, the scan data that's being overlaid with the new design information to see some of the various tasks that we were doing. So again, in summary, using the reality capture process allowed us to identify a lot of these issues, resolve any construction coordination issues prior to starting construction on site, reducing this.
Okay, so before we continue, I hope we did a good job about, dictating what we did through the project. And the reason why I say that is some of our team members are here, right? Like Jessica, Darshana, Cindy were a big part of this project. So they're here to make sure that we're in check and we're saying the right things before we commit to anything. But moving on to another large scale project, East Harbor. East Harbor, what we did here was we looked at UAVs as a solution, so using drones. It's a 3.5 acre piece of land. There's a lot of existing abandoned buildings. The buildings have a lot of history, so there is some sensitivity behind them. We were tracked to remove the utilities and put in the new utility systems, underground services for the future condos that are going to become going onto the site. One of the big ones was a water tower addition. So how did the UAV drones help us, in this project? Well, one was through inspections, verifications of locations. What do we mean by that? By going out there, having the drone, having the photogrammetry, we're able to put it on a software platform. Our team is able to investigate and locate areas or maybe, utilities, manholes before they go on site. It's a large site. It's like a needle in a haystack walking around trying to find all these. They're able to determine it, where their locations are, with georeferencing, right? So they have the coordinates. So it's very simple when they need to go out there on their tours and do their site visits. They know exactly where they need to go and locate these things. What that does is it increases efficiencies, right? And it also reduces any kind of safety, the potential hazards that we might have walking around in a site that's really hasn't been cleaned up. It's just one big mess, if you will. We also use it for quantification. So with photogrammetry, we're able to pull quantities to determine some of the excavation we're going to do, and eventually, as we continue with the progress, what the backfills we're going to do, quantity of backfills. We did it for progress tracking, so putting in a platform where we're able to do sections in an area that we're excavating, and do weekly flights, bi-weekly flights, whatever we need to, or at milestones, and be able to determine how far have we excavated through the georeferencing and accurate measurements. And eventually, one of the big things that we never encountered until the channel was brought up is the water tower. The water tower was the one piece that the client was debating about: do we tear it down? Do we keep it? Do we retrofit it? Because of its heritage and its history. Well, what condition is this water tower in? Well, instead of having a crew climbing this tower and figuring it out, drones came into play for that. We flew our drones. As you can see, we got some really close images to really determine what the condition of that water tower is. So then the client can make, a very good decision on sense of how we're going to move forward before they do. Eventually, it was torn down. So, but it did help decide of what direction they were going to go.
So the last project we're going to talk about as a case study is an example of a heritage and restoration project that we used extensive reality capture on. The purpose of this, as we know, that heritage projects typically require a higher level of documentation to document where things are at, being a heritage building. So this is an example of how we use reality capture to help mitigate risks on large complex heritage restoration project. So the example that we're going to be using, it was 4 buildings ranging from 10 to 24 stories, connected by a 2-story podium with some underground parking. Approximately 1.7 million square feet gross building area, multi-year project involving basically restoring the entire exterior of the building, any heritage elements, demolishing all of the building interiors back to the base building and retrofitting it with new mechanical, electrical, and architectural finishes. So like I was saying, heritage projects usually require special attention to documentation and preservation. So we chose to use laser scanning to document the existing conditions at the start of the project. And this helped our heritage consulting team as well, that we captured all this information and data, and they were able to use that to help determine what was going to be restored, how we're going to help protect some of this information during the construction. So it was a tool that our heritage consultant was able to use and supplement to their site visits and things like that. But they're able to review the information digitally. And as George was mentioning, gaining access to certain areas of the building that would normally be difficult or unsafe to be able to access. So the consultants can review the existing site conditions digitally using 360 photos, point cloud information, taking measurements so that we can make educated decisions on the information that we're presented with. So the more information that we have, the better the decision-making process that we can make at the end of the day. So we were able to identify and track issues from beginning of the project through construction to final inspection. And this helped to determine the extent of protection that was required, whether it's hoarding during construction, protecting the structure permanently during construction. At the end of the project, we did another set of scans to document the exact as-built conditions of how everything was actually built. And that serves as a form of, I guess, insurance to us as the general contractor that we've done everything correctly, we've documented it, and we're providing that information to the client, which would then eliminate any sort of future deficiencies, any risk later on down the road for insurance claims and things like that by properly documenting things at the end of the project. So like I mentioned, it helped to mitigate future insurance claims, deficiencies, and any issues. So in addition to all of the laser scanning and documentation that was done on site, the project team captured approximately 95,000 360-degree photos as well. And we use software to put those photos on drawings, on pins on a drawing, so you can click on a drawing, look at the location of the photos, and you can use a slider to kind of view time lapses of different photos that were taken at that location throughout the project. So just having an extensive level of documentation on these heritage projects proved to be extremely valuable and useful in our case. So we've got a video here that kind of walks us through some more information on this.
PCL's virtual inspection workflow creates a 3D digital twin of a building exterior. These high-detail inspection models feature lifelike textures at dramatically higher resolutions than laser scans, making them ideal for visual identification of issues and defects. The virtual inspection process streamlines initial issue assessment, tracks repairs throughout the project lifecycle, and delivers a true-to-life exterior as-built model for future building operations. Prior to full site mobilization, our in-house experts will conduct a high-resolution drone scan of the Assiniboine College exterior to create a photorealistic cloud model accessible to the entire team. The team will utilize the super high-resolution model to inspect, collaborate, track, and quantify repairs in advance of erecting scaffolding. Throughout the project, the team will collaborate using the virtual inspection model to discuss, document, and action exterior restoration work. After completion of exterior repairs, PCL will rescan the building and deliver an as-built facade model, providing Assiniboine College with a complete virtual snapshot of the building exterior.
So moving on, the last topic that I'm going to talk about is the using reality capture for QA/QC verification. So there's a number of different examples we've got shown up here and numerous projects that we've used these types of things on, but using reality capture to verify construction tolerances, whether it be site grading, underground service installation, using a UAV, capturing rebar and in-slab mechanical and electrical services within a concrete slab prior to placing concrete in order to document where your rebar in-slab services are, if there's future cutting or coring required. Can be done through laser scanning or through UAV. Measuring concrete slabs, slab elevations, topography, what's happening with your concrete slabs. Are they flat? Are they not flat? Are there deviations? How much are those deviations? Looking at elevator shaft plumbness, making sure that our elevator shafts are vertical before your elevators show up on site, making sure that your construction tolerances are being met prior to things arriving on site and then not fitting. Basic things like that the reality capture in lieu of doing older processes, manually taking measurements, things like that. There's an opportunity to use reality capture to make this information more available, more accurate, faster, quicker type of thing. Using it for curtain wall and window opening dimensions, verifying that the windows are going to be able to fit within that opening, confirming shop drawing dimensions, verifying and document basically anything that requires high accuracy and low tolerances. So we've even used it to verify building, tree, and power line locations to help plan a flight path for an existing helipad at a healthcare project. So there's some sort of inside the box ways that we can use reality capture, and there's some outside the box ways that we can use reality capture, and we encourage everybody to explore some of the in the box as well as the out of the box options for QA/QC verification.
So one thing I want to point out here as well is Andrew and the reality capture teams and everybody does laser scanning. They're only going to be there and service what they are asked to do. So our project teams have fallen into and believe and see the quality and the opportunities. And they're the ones that sometimes come up with the out of the box thinking. A lot of the things that Andrew just mentioned in the end, that's our project team coming to Andrew and saying, hey, I've seen you do this. What do you think of that? And then using his expertise in the technology to come up with solutions. So it's a win-win between the project team and the services that we provide, which we feel is coming because of that out of the box thinking. Well, we wanted to share some of that with you in the sense of, yes, you could do as built and it's laser scanning, but there's so much more we can do. The floor flatness, as Andrew was alluding to, it is a sensitive topic because some people feel that it's not a legal binding way of looking at imperfections. But hey, if you do the scanning and there is a big question on it, then you can manually check to see if there is a problem, and then you could face it. You could face it before you get into the finishes. So again, it's just tools that are given to us throughout this whole day today. You've heard of a lot of different tools, and a lot of them are leading towards solutions, and that's what we do. We're solution providers. So here comes the next topic, which is a one slide. And funny enough, I used AI to create this image for me. So because I wanted to bring it up. And to some degree, I'm going to read this because I just don't want to watch my words, right? I don't want to come out across as a cynic, but I want to be realistic because that's been my MO my whole career. So looking ahead, reality capture is positioned to play an increasingly vital role in construction, driving by advancements in automation, artificial intelligence, and integration with digital twins. Today's platforms offer partial automation and still rely heavily on skilled forces. So that is an upfront cost, which sometimes deters projects, teams, or companies to invest in. The ongoing innovation is steadily addressing these barriers, though. So we are seeing improvements as we move forward. AI, to me, is a fully automated solution, not a partially automated solution, right? So a lot of companies out there, a lot of vendors are claiming AI. Some of these products we've been using for 10, 15 years ago, and all of a sudden now they're AI, but they're performing the same task. So how did they all of a sudden become AI? So we have to, as in the industry, we have to be cautious of what we want to accept as AI. We gotta also realize that we need to back check any information that comes out of an AI, right? We can't just blindly say, this is the solution. And I feel that right now, we have, especially in scanning, there are some issues that we have to overcome. Files are large, so we need to find out how to get these compact. We went into a couple of projects here that through trial and error, Andrew found out that a certain file size is acceptable to put in a software platform to have it in the background. If you get bigger than that, software's crashing on you. You can't do more than that. So we sort of figured out how to chop it up in little chunks so we can do that. Cost, I brought it up before, I'll say it again. It's autonomous, and reality capture is evolving, right? So we're going to continuously look for solutions, and I think they're going to be there. I just question if they're there today, right? AI and machine learning are already demonstrating value in interpreting this data, detecting changes, identifying risks, generating actionable insights. These capabilities are laying the groundwork, right, to the future of what we can be doing with reality capture. The integration of reality capture and digital twins is transforming, and how we manage buildings and infrastructure across their life cycle. And as AR, VR technologies mature, they're enhancing collaboration, training, and remote inspections, bringing stakeholders closer to the job site without being physically present. While the full vision isn't realized yet, the trajectory is there. I remain optimistic, and I hope to see that within my career lifespan, which I don't know how much more years I've got left, but I mean, we are moving in the right direction. We are. There's still a lot of work to be done, and sometimes what stagnates us is the technology, in the sense of, can we handle what's being done, and then the cost that's associated with it. So I think when those start coming together, I remember products, and I would date myself, and AutoCAD used to be a very expensive tool once upon a time, right? So, but in years to come, and as it became stronger and better and the industry welcomed it, it became feasible. And I think that's what we need to see. But we also need to handle that information, which right now is a hard thing to do. But we want to thank you for your time, and we really appreciate it. Hopefully, we gave you some insights to think about walking away. And we're open to any questions that you may have.
All right. Anybody got any questions for our friends? All right, the biggest competitor in the room, now let's go.
Great presentation. Thank you for everything you've shown us. I was really blown away with how detailed your reality capture was. I'm just curious, how did you get that much of a detail from from drone photography and be able to find defects and spalling and all that kind of stuff? Did you combine both laser scanning and the drone together?
So what I'll do is I'll give you the big term. And
Yeah, give me the big term.
Then I'll pass it on to this guy.
Good.
The real thing is that sometimes we're too quick to go in to capture what needs to be captured and walk away. Right? So if you don't take your time to plan and set that up, and Andrew and I have said for the last 2 years, trying to come up with a plan that we feel works, sometimes we lose some of that, intricacies and details.
Right.
On the technical side, I'm gonna pass it over to Andrew.
Yeah, great question. And yeah, it is a combination of that particular example is a combination of laser scan data with the drone information. So I did forget to mention that video was put together for us by our PCL Saskatchewan office. So it's not just us here in Toronto that are doing these things. It's kind of all of our PCL folks across North America. But it is in that case it's a combination of high quality scan data, high dense scan data, put into a small triangle count or a large triangle count mesh to give you that level of detail. So a lot of it is and I guess I'll speak maybe to the limitations to some of the softwares out there is the amount of computing power. Generating something like that does take a lot of processing and computing power, and making sure that you've got the proper computer specs and hardware in order to do that, so that it's not taking days in order to generate a mesh from a point cloud type thing, is also something to consider and very important.
Thank you.
Yes.
So yeah, everyone can hear me? Yeah. Okay, so the data for the laser scanning data for SketchUp, I assume you guys use it for internal coordination works. Have you shared this with designers for design coordination? And if yes, so how they find this really useful for them?
Yeah, so history is on that project for the Scotiabank is the designers were challenged and they brought it up to the client saying we have outdated information. Again, our project team being wise of what we do said, hey, we do scanning internally. So the whole purpose behind it was actually for the designers. And that's what we were contracted to do, is capture it for the designers so they could design around it. And then obviously having that kind of data, we took advantage of it for everything else because we did do the modeling as well, right? So for them, so we present, you have the scan data, but as we said before, the files are large. So we created the models for them as well because they didn't have the capacity to do so. And then capacity meaning the power, the people power. And so we were able to do that for them and then provide them the model with the scan data. So yes, it was for design and we just took advantage of it after that.
There's one further.
So I had a question about laser scanning, like you mentioned, there's anything about your ceiling and you scan that. So let's say there's two ductwork going and the designer wants to install a new ductwork between those two and you laser scan that. Does it tell you accurately what's the gap between the two existing ones, or do you at the end of the day have to go physically and measure it with the tape?
So the laser scan data, it will give us all of that information. So the way that the scanner works is it's capturing millions of points, or depending on the hardware, thousands or millions of points, basically in 360 degrees in all directions. So as long as you can see that distance or see between those two pieces of ductwork, and you were able to place your scanner in a position that's able to capture that, you would then have a copy of that digitally, and you'd be able to take those measurements using the software. So that eliminates going out onto site to do any measurements or verifications or things like that. It's all done digitally in the point cloud on the software.
Any other questions? Alright. So it's funny, Elliston had the most questions for this session, and on the Elliston one, PCL had the most.
Scratch each other's backs.
There you go. Alright, so please, big round of applause.